Okay, so hope you guys can see my screen. Can you see my screen?
Yes, we can see your screen.
Okay, okay. So we are going to be looking at the task, this security application. I don't know, is it possible that anybody can explain this diagram the way they understand it? Yeah. Is there anybody that's willing to explain the diagram, or nobody knows how to interpret architectural diagram?
Okay, I would like to give a shot. Give me a second to just collect my thoughts.
Okay.
Okay, so this is this what we would say? So we have the bastion, we have this. Just okay. So is this a two-tier application? We have the public subnet. Okay. Anyway, basically, we have an application that is sitting in the VPC
Okay.
hosted to availability zones, right? Now to within the availability zone, we have the instances, the private instances that I don't know host the application
Okay.
uh, in one of the private subnets, and I believe RDS is the database that is in another subnet, right? Um,
Yeah.
Now, those instances are not expected to access are not expected to be reached from the internet directly. So we have a public subnet that this is a bit confused, so I'll just keep it at that. Now we have the load balancer that uh, manages the traffic between the two availability zones, right?
Okay.
Of course, working in conjunction with the security group, um, yeah, to determine what can be reached or what services can be reached. Um, so the gap, I mean, this is a very rough sketch, but where I'm not even able to touch in my sketch is the public subnet, the bastion. I still get the concept of that very well.
Okay.
I believe the NAT gate probably gives the other subnets in the second availability zone some, if I remember well, I think it's also a way to reach to go out to the internet or something. I don't get that part very well. So anyway, that's my rough try.
Okay. Okay. Is there any other person that wants to try to explain what this diagram is and exactly how you understand it? Okay, so it seems that it's only one person that basically understands the diagram. So this diagram is a three-tier diagram, meaning that it has like a front end, the back end, and the database. Yeah, and you can see the front end is basically in the private subnet. Backend also is also in the private subnet, and the database is also in the private subnet. Yeah, and we are basically running the front end and the back end with auto scaling group. right? That's why you can see ESG here, which stands for auto scaling group. This is the front end of scaling group. Yeah. So if the load increases, it can automatically increase. Yeah. And same thing with the back end also. If it reduces, it can automatically reduce. So where the version host comes in, like I explained before in our previous classes, a version host is just like the main point of the version host is to basically SSH into a private instance in a private subnet. And the version host must always be on the public subnet. That's why you can see the version host is on the public subnet here. And we can use this version host to log into our front end server and check if maybe we're having a particular issue or error, we can check it. Same thing with backend. Yeah. And another thing that we are also looking at here is the NAT gateway. Yeah, so we want the front end to be able to access the front end or the back end to be able to access the internet. And the only way we can do that is through the NAT gateway. And the NAT gateway also has to be connected to the public subnet because there's internet connection in the public subnet due to the internet gateway, right? So because of the internet gateway, we have like internet connection in public subnet, and because of the NAT gateway, we have internet connection in the private subnet. Yeah, and now we have our load balancer, right? That's going to basically route the traffic from our auto scaling group. So our auto scaling group is connected to our load balancer, right? And yeah, that's basically all you need. And lastly, you can see the RDS, right? Which in this case is going to be MySQL. Yeah, yeah, you can unmute your mic, please.
So please, if you can go back to that diagram, you said there are three private subnets. So you say it's three tier. Okay, nice to hear
Yeah.
that. I didn't want to risk that. So it's three tier. I see why. Okay, but you say there are three private subnets. I see two. I mean, within each availability zone. How is the third one?
Okay, these are three-tier applications, right? You can decide to create three different private zones. Did I say there were three private zones?
No, you said there are three private subnets.
Oh, three private subnets. You can decide to create three different private subnets, or you can just decide to put what's it called, the backend and one backend and one front end in the same availability zone under the same subnet. Do you get what I'm saying?
Yeah,
Yeah.
yeah, I do. I do. I mean, it's fine. It's just when you said there were three, I was confused. Maybe I missed out on. I can only see two, right?
Yeah.
Per availability zone. But it's fine. I was just confused about that.
Yeah.
Okay.
So basically, that's all about this architectural diagram. And also, like I said, the RDS is an MySQL instance, right, on AWS. So yeah, it's best to create like a database that is basically present on a cloud provider. Yeah, it's better to create a database that is present on a cloud provider than you create a local database because definitely the where you're actually hosting it or the cloud provider you're hosting it will basically protect your data more than you trying to um, run the database locally. So this is everything you need to know about this. And lastly, this is the internet gateway. This is the internet gateway. So you need to really understand the symbols that are used here. Internet gateway, NAT gateway, application load balancer, right? And this is for EC2. This is also for EC2, and this is for database. Yeah. So if we now look at the code, if we now look at the code, the first thing we want to do is we want to be able to set up S3 bucket. Yeah, we want to be able to set up S3 bucket. So meaning that all our Terraform files or our Terraform state files are going to be stored in S3 buckets, right? And basically, this is actually very it's something that I will really advise you to always do. And if you check the provider.tf file, you can see our provider, just like every Terraform file, we have the AWS and the region. And we go to our S3 section, you can see we're creating a particular bucket, right? We're creating a particular bucket and we're basically AWS S3 bucket and also giving it a versioning, right? And we are also basically encrypting this bucket. And if we basically look at the DynamoDB, so now we're basically using DynamoDB tables. This is because we want to be able to lock the bucket, right? We want to be able to lock the Terraform state file, meaning that anytime we're running the Terraform state file, because if you're actually working in an organization and you guys are working on an infrastructure, yeah, and you make changes to the Terraform code, and let's say someone else makes changes to the Terraform code, I get what I'm saying, and you guys basically run the script together, right? Then yeah, you guys will basically have like an error where you like there'll be an error in the Terraform state file, right? Because basically two people are running together and it can actually affect the infrastructure. So the best thing to do while you're creating all these things is to have like a DynamoDB table, which helps us lock the what's it called? It helps us log the Terraform state file, meaning that if one person is running the state file, another person cannot run the state file. I guess the person will have to wait until that person is running the state file. And this is basically the section we are going to be using to be creating the DynamoDB table for our Terraform state file. And if you look at the variables.tf, you can see all the variables that we're going to be using, all the variables that were listed out, right, in every single file. Every single thing is listed here, right? And that is the that's what we basically look at in the backend, right? So just know that is something that's very, very important because your Terraform state file needs to be remote. It's not something that should be on your local machine. It's something that needs to be remote. So when we scroll down, we can now see modules. Yeah, you can see modules. These are the two things you should really focus on: the modules and the Terraform. All right, and this is the one we want to look at first because we're going to be writing every single thing in modules. So if you open this down, you go to our main.tf. The first we have is compute, right? So the compute helps us create all our um, auto scaling groups for the front end, the back end, and yeah, for just the version host rather, the front end and the back end, right? So if you come here, you can see we are basically creating our key for the version host, right? So this is the key we're going to be creating for the version host. And we're also basically filtering out the Ubuntu machine AMI ID, right? Which we're going to be using for our launch templates, which we're creating here. And this is the launch template for the bash host. So you can basically see that here, launch template and auto scaling group for bash and host. And you can see the name prefix, you can see the instance type, every single thing here is a variable. And if you scroll down, you can now see the auto scaling group, right? So before you create an auto scaling group, you need to have a launch template. That means you need to tell the auto scaling group that okay, these are the things that I have basically put down that I want to be like in my instance while you are creating this instance. Do you understand what I'm saying? So you give that to the auto scaling group. So for instance, if you want your auto scaling group to be able to anytime it pulls up new what's it called? Because you know the auto scaling group, the main job of the auto scaling group is to help us to increase and reduce the amount of instances we have based on the load that is basically getting or the amount of traffic we're getting to either our website, right, or to our application. So basically tell you that okay, run this particular command when every instance is basically coming up, or when you are trying to create every instance, run a particular command. Either is sudo apt update or sudo apt install. You want to basically run your what's it called, and we can do that using user data. If you scroll down to the launch template and auto scaling group for the front end app, then you can see that here we're basically using user data and also the file base64, right? And this is the file we want to run, clients.sh. I get what I'm saying. So you can basically write everything in a script and basically pass that script into your launch template. And this tells the auto scaling group that okay, anytime you're trying to launch a new instance, always run this command. So that's also very, very important. And also in the auto scaling group, you can always see that there's a minimum size, there's a maximum size, and there's a desired capacity. The desired capacity is the amount of instances you want to run right now. So the minute you run all this, the amount of instances you want to run now, that's basically what's going to come out as the desired capacity. Minimum capacity is depending on the load that we have, right? If the load is basically lesser, we want it to reduce to 2, and maximum capacity is depending on the load. If the load is more, we want to increase it to 3. So yeah, that's basically everything you need to know about the scaling load. And when you look at it depends on, now we're basically telling you that it should depend on the scaling group, right? The 3-tier backend to be created before it is actually created, right? So we want it to depend on the backend to be created before it is created. And if you scroll down, you can also see that the launch template and auto scaling for the backend. This is where we're also running the user data, the API.sh for the backend also. So every single time it spins up a new machine or it spins up a new EC2 instance, this script is being run for every single EC2 instance. So when we scroll down again, you can see all the whole scaling group and all the configuration that we're going to be adding to this. And lastly, you can also see the resources, right? This is the resources for the auto-scaling attachment. And we're basically attaching this to our load balancer, right? So we're attaching this to our load balancer. And this is basically for the front end, the 3-tier app.id. Yeah. So when we go to the output.tf, so the output.tf, we have the app auto-scaling group, the app backend, the auto-scale backend, the auto-scale front end. And when we look at our variables, you can see the number of variables that we have here. These are all the variables that are basically placed here. And don't forget that this is a module, right? So we're not going to be basically like writing all our variables in this variables.tf file. We're going to be passing everything. We are going to be passing everything through our main.tf file here, which is going to be holding every single what's it called? It's going to be holding every single variable, right? Like our SSH key name, our key name. Then we have every other thing that we're basically referring to, like the version host and the backend app and the front end app. We're basically referring that as a module. So yeah, we're basically referring as a module back into the network dot front end underscore security group, right? So and we'll get to that section in a bit. So when we come to the database section, here you can just see that we're basically creating the AWS DB instance, the 3-tier DB. You can see the engine, which in this case is MySQL. You can see the username, you can see the password, you can see the DB name, right? And basically that's just all for the database main.tf. And when we go to the output.tf, the only thing we're printing out is the endpoint, right? That's the only thing we're printing out. And in the variables.tf, you can see every single variable that has been created here. This is every single variable that we're going to be using, or this is every single variable that we basically referred in our main.tf file. So when we close this and we go to our load balancer, when we go to our main.tf in our load balancing, you can now see that we are basically creating an internal facing load balancer, right? Application load balancer. We are creating our target group, just like the normal way we will create normal load balancer. We are creating our AWS load balancer listener. We are also creating a load balancer for the backend. Yeah. So now there are two load balancers. Yeah. Although it wasn't basically shown in this diagram, but there are two load balancers. The first load balancer is the load balancer for the front end and back end. Yeah. But the second load balancer is the load balancer that's going to be for from the front end to the back end. So the first load balancer is the one that is basically taking people's requests, right? So if you visit a particular website from the load balancer's DNS, right, that's the first load balancer. It takes your request and it passes it to the front end application, right? Now, the second load balancer is going to be called a network load balancer, although it is written as application here, which was a mistake. It's supposed to be called a network load balancer. That's supposed to take the information from the front end application to the back end application, right? So that can basically pass data and basically um, remove data from the backend also. So that's also, and it can also store what's it called, data. Like for instance, you put in your name, password, all these kind of things. It can basically pass that. And when you look at AWS load balancer target group, we're also creating that too. And the listener, we also created the listener too. So basically, that's all you need to know for the AWS load balancer. And you can see the output. We're also calling the load balancer endpoints. We're calling the load balancer target. We're calling the load balancer target group, and also the load balancer DNS. So when we close this and we open our networking, so our networking is where we have all our subnets, right? We have our VPC, we have our internet we created, we have our AWS subnet, we have our AWS route table, we have our AWS route default public route, right? And yeah, we have our Elastic IP, we have our NAT gateway, we have our AWS subnet for the private subnet, yeah, we have our AWS route table for the private route table, and we also have our security groups, right? So we have a security group for the version host, we have a security group for the load balancer security group, we have a security group for the backend, we have a security group for the front end, right? And we also have a security group for the load balancers backend, right? Which is also present. Lastly, okay, it's not the last. We have another security group for the RDS. This is the RDS security group, which is open on port 3306 rather, which is the MySQL port. And if you scroll down, we have the database subnet group, right, which is also created here. So this is basically everything we need to check in the modules section. When we go to the Terraform section, you can now see basically everything is created. And if you check our main.tf, which is like the most important file here, you can see that our provider is AWS. You can see the locals, you can see the instance type, you can see the location, which is in case US is one. You can see the environment, you can see the VPC CIDR block. Also, you can see all the values that are supposed to be present in the networking section, which is the access IP, the public SN count, right? And also the availability zones, right? So when we go to the compute section, you can see now, if you look at this top, right, just like the way you write a module, we have the source, which is basically telling it go 2 steps out of this particular directory and look for your directory called modules and to find the directory called modules. And after you look for modules, find another directory called compute. So when it opens this, it's going to see a directory called compute. And when it opens compute, then automatically Terraform knows that it is going to basically look for each and every of these variables that are here. And yeah, so that's just how it works. And when you scroll down, you can see the database section, right? And in the database section, we can see our database storage, you can see the version, you can see the DB instance class, right? Which is in this case a T2 micro, so DB micro, right? You can see the DB user, the DB password, yeah, and everything is created here. And also in the load balancer, our own load balancing, you can basically see all the resources that we need basically created here. And when we go to the output section, we can see we're also waiting for the load balancer endpoint and the database endpoint. In the providers.tf, you can see that we're also storing every single we're also storing our TF state file. We're basically storing that in the buckets that we created, right? Remember, we created buckets in the backend. That's where we're storing all this. And we have the region, which is US is one, and we have the DynamoDB table, which is state log, right? And yeah, the backend, which is also S3, because everything is basically created in an S3 bucket. So when we go to this variable TF vars, you can now see all our what's it called, our DB name, our DB user, and our DB code, right? So this is the name we want to call the user, which is in this street here. This is the user, which is root, and this is DB password, right? Which is admin 123. So yeah, that is basically how we are going to pass everything that you're going to need, which is in this case the DB name and the DB password, because it was not stated in the module. So we're basically using a variable.tf and while we are going to be pushing this to your GitHub repository, do not push this variable.tf because it's actually a bad practice. Yeah, you basically want to just use like an env or .git ignore file to ignore these variable.tf, right? Someone that looks at this code will automatically know that yes, it's supposed to be variable.tf. And yeah, so we basically have everything created here, right? Everything is perfect. And that's basically everything you need for this 3-tier application to be running. Now, when they are running, the 3-tier application is running, which is the front end, the back end, and also database infrastructure, right? They are all running. You can now decide to say you want to host like a web application with a front end or a back end, right, on it. So, is there any question so far? Do you guys have any questions so far?
Hello? Can you hear
Yeah, I
me?
can hear you. Yeah.
I think what are we trying to deploy here? I don't really understand that part.
Okay. What are we trying to deploy first? Yeah.
Yes.
Okay, we're trying to create an infrastructure. You get what I'm saying? That's what we're trying to do. We're trying to create an
Okay.
infrastructure, a 3-tier infrastructure, right? Which in this case you will basically create like using Terraform, which is like an IAC tool. You create an infrastructure that can host a front-end application, a back-end application, and a database application, right?
Okay.
So this is actually something that you most likely come across while you're working like an on-site job or a remote job or cloud role, right? You sometimes you might be asked to create like a whole infrastructure that basically hosts their web application, right? And this can also help you with that. Is hope you understand it now.
Yes. Thank you.
Okay. Is there any other question? Do you guys have any other questions? Okay, so since there are no other questions, I'm just going to try to run this. So let's add rules and IPv4, HTTP, also on IPv4.
Are you creating this as the as your what is it now? Um, your workstation, so to say. That's where you want to. That's where you run from.
Yeah. I'm
Okay,
going to run everything from EWS.
okay.
In this
Because one
instance.
can just do it on his desktop if he wants, right?
Yeah, you can do it on your desktop.
Okay.
Okay, so we've created our public subnet. So let's reload this and select the public security group rather. So we're going to launch this instance. So instances, so wait for this to basically launch. Okay, so it's running now. So let's connect to it, and we can connect using EC to connect. So let's cancel this out. Okay, so first thing we want to do is we want to, so if we basically come over here, we can basically take our installer.sh file and use it to install everything we'll basically be needing. So this and come over here and nano. So if we place this here, we can remove the parts that we do not want, which in this case, Jenkins, we're not going to be installing Jenkins, we don't need Jenkins for anything. And we will be using kubectl too. Okay. Li. Okay, yeah, we'll be using that. And okay, so we can just save this, Control O, enter and Control X, and we can make it executable. We can run it. Okay, so while this is running, let's create our IAM user for Terraform. Okay, so we have to go to the user section, then create the user, then give this user a name. Let's call it Terraform. So next, attach policies directly and admin administrator access. So scroll down, next, and yeah, create user. So now go to this user and we are going to create our access and secret access key. So local code and take this next, then create key. Now we have our access key and secret access key. Let's just download that. So yeah, we have that, and let's just wait for this to run completely. Okay, so now that it is done, if we basically check Terraform, check AWS configure, yeah, so it's basically installed. So now let's take our access key and our secret access and our region, which is US East 1, and JSON, which is the format, right? So if we basically now clone this our application that we have here, so the code, copy this and git clone. Okay, so and now if you see into the infra application, we can basically see everything that we need here. So we just need to see into the Terraform section and do a Terraform init. Okay, so the first thing we need to do is to actually go to our backend to create the backend first. So we need to create our S3 bucket first, which um, is like an error here. So we need to do like Terraform. Okay, give me a minute, please. Okay, so if we come back here, we'll have to do like a Terraform init. And a Terraform apply dash. Okay, so it is created already. So if we cd out of here and we basically cd into our Terraform directory, we can now do a Terraform init and to be able to detect our S3 bucket that was created. So you can see successfully configured the backend S3. Terraform automatically use this backend unless the backend configuration changes, right? So we have everything set. The next thing we need to do is the Terraform apply dash auto dash approve. So if you run it this way, you definitely get errors now because you'll be asked to basically pass in the values directly. So if you keep pressing enter, keep pressing enter, keep pressing enter, you get like an error at the end of it saying yeah. So this is the error. You have like it's not valid, right? So the cider block is not valid. So basically what we'll have to do now is we need to use the dash var dash file is equals to variables. Is it variables? Is it variables? Okay, let's check. Okay, variables.tf var. So variables. Okay. Okay, so let's try that again and enter. Okay, so basically it's going to create every single thing on AWS. Yeah. So yeah, that's just everything you need to know. So you can see the 43 to add, 0 to change, 0 to destroy. And it's going to take a while to basically run all this on AWS. So if you have any questions, you can ask now. Are there any questions so far? Does anybody have any questions so far? Or does everybody understand what was taught so far?
I don't really, hello?
Yeah,
The link to these repos.
yeah, you definitely get it. You definitely get it.
Okay.
So what I'll just say is you can basically take the whole code and replicate it on your GitHub portfolio or your profile. Yeah, and basically write the documentation. I mean, everybody right now should have the architecture diagram with them. You can put the architecture diagram and basically write the documentation, understanding writing is the way you understand it rather. Yeah, this can basically help grow your portfolio. Okay, so just wait for this to run. So this call ends in 3 minutes. Okay, give me a minute. Let me see if I can create a new meeting link. Okay, so if we basically come over to our AWS account, we should be able to start seeing everything. So if we check for our instances, which is EC2 in this case, okay, so you can see we have two instances that are currently running, right? And this is the version host that's running now. The front end and back end is not yet running because everything depends on the database to be created before it is created. So it's not yet running, right? And if we go back to check our auto scaling groups, we can see one auto scaling group present here, which is for the version host. This is the auto scaling group. So if you come back to delete this instance, right, it will always generate a new instance for you. Yeah, it will always generate a new instance for you. And if you check all the security groups, you can basically see all the security groups that are created for the backend, for the backend tier, the load balancer, the front end, every single thing, the RDS, all the all the app infrastructure we're going to be using. We have like a security group for it. You can see our Elastic IP. You can okay, our load balancer is not yet created. Okay, so it's now creating the auto scaling group for the 3-tier backend. Okay, so you can now see we have 4 instances running with 2 auto scaling groups. Let's see if we can reload that again. So let's see which one actually is creating. So if you come here, you can see that we have the 3-tier front end app, the 3-tier backend app, the 3-tier backend app, and the version host app. We also have another 3-tier front end application that is also just booting up. And if you check again, you can see now that there are 3 auto scaling group, one for the version, one for the backend, and another one for the front end. Yeah, so now we can see we have 6 instances that are currently running, right? And yeah, so we're waiting for the load balancer to come up. Okay, so let's give it some time. Okay. Yeah, so is there any question based on anything? Do you have any question based on anything? Is there any question at all? Okay, so we can see our load balancer now. We have 2 load balancers here. And if we drag this down a little bit, you can see that there's one that is for the back end and there's another one that is for the front end, which is this one, right? And if we it's still trying to provision, so yeah. So basically, that's everything you would basically need to know about a 3-tier application, right? Another very important thing is basically destroying all this. And we can also do that again using Terraform. We can just use a Terraform destroy and we're going to destroy everything. So hope that's clear. Do you have any questions at all?
Hello. Sometimes when you run that Terraform destroy,
Okay.
there are some of the there's some of the resources that will still be running. It won't just destroy everything. I don't know what. Maybe it's my own, or maybe I'm not doing it well. I don't know.
Yeah, Terraform basically destroys everything that is created or everything that is present in the TF state file. So if it is present in the TF state file, it will help you automatically destroy it.
Hello, please come again. You said everything inside.
Inside the TF state file,
Right.
inside the state file, right? So it will help you destroy everything. If there's nothing that was created by Terraform, Terraform won't destroy it when you run your
Okay.
Terraform destroy.
Okay. 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 Like at the beginning, you try to run for the S3 bucket. It didn't run. So you went to
Yes,
run that S3 bucket stuff first before running this
yes,
one, the current one. So
exactly.
if you're going to destroy now, we're going to start destroying with this one you have,
Yeah,
the one that
we're
is
going to start
running now,
with yes, before you
before
destroy
going for
the
the S3 bucket stuff
exactly. Because if you destroy the S3 buckets, then the TF state file isn't going to be available anymore, meaning that you have to destroy everything manually on
manually.
AWS. Yeah.
Okay. Thank you.
Okay, so you can see now that everything is created. You have like our resource, you can see our load balancer endpoints, you can see our database endpoint. You can see that everything was created, right? And now if you want to destroy it, just like the same way we created it, right? In this same directory, all we just need to do is we need to change this apply from apply to destroy. And when you click enter, it's going to destroy everything for you. Everything that is created for you, it's going to destroy it. And you have to do this first in the um, Terraform directory before you do the same thing in the backend. So right now, if you even come back to check our EC2 dashboard section, now we try to reload this. Now you can see it's basically deleted all the instances that are running. It deleted all the auto scaling groups that are running. And you can see we have 6 instances, right? Which means the ones that are deleted are also present here. And our security groups, which is not deleted yet. Okay, so we just have to wait for that. So you're still deleting the DB instance. Okay, so basically we're done, right? When this finishes, we're basically done with the whole destroying and deployment of the 3T application. So if you have any questions, you can ask now or before or after we go, you can basically send a message to the mastermind group.
Okay. The link to the repo, as in, I don't know where as to get it.
Yeah. I'll send it to the group. I haven't sent it yet. I'll
Okay,
send it to
thank
you so you can access it. And also, there's going to be like another task for Docker. I'm going to be dropping more details on the task so you can basically get more like idea of how Docker works and how to use Docker.
okay.
Okay, so it's done deleting the database, and yeah, everything is deleted. So if you go back to our AWS account and reload this, we will have all our security groups deleted. So now the next thing we want to do is we want to cd dot and we want to cd into the backend, and we want to do a Terraform destroy. So yes,